Good morning, everyone, and welcome to the last session of software carpentry. Today we will see SQL. That is a tool to manage and organize data and do some queries related to data. We have seen in the first day we show make, that is to automate tasks and things that we need to do for our research. The second day we use JIT, that is to keep track of the changes that we have done on the scripts and the files that we use. Yesterday we saw Python, that it is the programming language that is useful uh, for handling data, create plots, etc. And today we will see SQL. So first of all, I will share the link of the lesson that we will follow. So you will see it. Yes, that one. And I will share my screen. Just 1 second. Guest. Okay, so I have this. Okay, just to show you, this is what we will. This is the website that, well, the lesson that we will follow. Okay, we'll make this window like a little bit smaller, that you can. So first of all, for this lesson, we will need SQLite 3 or DB browser for SQLite. So it's up to you. But I will follow the lesson using the terminal. So using SQLite 3. And also you need to download, if you click on setup, you need to download that file, survey.db, that you have that in the chat. So what I will do is I will share my terminal now. Let's start with playing around with the database. Okay, so well, this is the terminal, and first, let me give you an introduction about a very short introduction about why we use SQL. Today we will work with the data. We will get some information about the some databases that we have, and you can see like different tools to manage data. One of them, you can save the data in text files. That could be an option, but the problem is that what we miss are a tool or a mechanism to read the data or to do some queries, sort the data, etc. So text files are a possibility, but we don't have the tools to handle if we want to handle queries, etc. Other options are spreadsheets, but they might work well with a small amount of data, but mm, depends because sometimes are not mm, you need additional software that is could be non free, or and also, well, if you check in the press, you find that it's not the best option when you handle large amounts of data. And the third option that we have is to use SQL. So SQL is a is a s- uh, is a tool that where we have a database and we can do some we can show the data, we can ask some queries, and we can get this data organized in the way that we want. So what I will do, well, let's start with the, so I'm in the terminal. What I will do is I will move to desktop where I have the file that I will use today. The file is called survey.db. So to use the SQLite, you need to type SQLite 3 and then the name of the file, that is survey.db. So if you click on enter, you will you press enter, you see that now we have a different prompt that is called SQLite. Uh, Today, well, there are a lot of SQLite is a database manager. There are a lot of them that could be MySQL, Microsoft Access, Oracle, etc. But the well, one of the advantage of this one, well, SQLite is like doesn't offer all the features that other database managers can offer, but the good thing is that you only need one file to, so you have the file and you can have a small database using that manager. That you don't need a server, or you don't need like a more complex installation. Also to mention that, well, SQL stands for Structured Query Language. We will see through the lesson today that the idea is to introduce some queries and get the data as with the format that we want. Also mention that, yeah, today where survey.db is a database, and the database uh, contains tables. Uh, a way to show the tables that we have is if we type dot tables, we get a list of the tables that we have in our database. So we have 4 tables: person, site, survey, and visited. Also, you can see the structure of all tables if we type dot schema. With that, we can see the structure of we can see the columns. Each column represents the type of the data that we have. For example, for the table person, we have 3 columns. We have an ID, we have a personal, that is the personal name, and family, that is the family name. So for site, we have Also the name that is in the name. We have a latitude and longitude. Also we have a survey that is taken, person, quantity, and reading. And also we have visited that is the ID, site, and dated. So you can see the all columns that the tables have. And these the columns can be known as fields, and also we will have rows that are the entries that also can be known as we can refer to them as records. So now that we know the structure, we will we will do our first query, that is to show a table. Let's start with person. So if we type select, uh, if here I can say which columns do I want. So I can say select family, personal, from person. Well, you notice that I finish all queries finish with a semicolon. And in that case, the database manager knows that the query is done. Yeah, this is a good question. This SQL, this language is not case sensitive. So doesn't matter if you use capital letters or if you use small letters. That is a format, for example, if you may notice that mm, the keywords that are for SQL, I type them in capital letters, and also the rest, the table and the columns are in small letters. This is like a way to a convention, a way to use that, but you can use this is like the most standard way to type SQL queries, but you want to type everything in small letters or everything in capital letters. I have seen, for example, with the previous when I work with the previous databases, some people did the other way around. They use small letters for the SQL commands and capital letters for the rest. But well, well, to be honest, was the first time that I found this. But just to let you know that if you work with other researchers and other groups, you can find different different ways to write. But yeah, just to let you know that yeah, it's not it's a case insensitive. Okay, so let's execute that. And where you see that the output is we have the first column is the family name and then the personal name. But you see that the format is a little bit difficult to read because the columns are separated with a vertical bar, and is to get the columns in a nicer format. Okay, the it's important if you don't use the semicolon like that. For example, I will remove the semicolon. I get this, and this is because you can now you can now add, for example, where, or you can keep adding information to the query. But if you want to finish, you type a semicolon, and it will execute the query will be executed. So yeah, this happens when you forget adding the semicolon at the end of the query. Okay, let's make the query like to show it in a nicer format. And to have a nicer format is you type dot mode column, and then to show the header of each column, you need to also activate that. So it's a dot header on. So now if we repeat the query, select family personal from person, you will see that the format is more readable. Now it's better. So you see the name of the column, and now you see the contents of the table. Also, well, if you want to select everything, everything means well, you need to use a star. Select asterisk. Select everything from person, and you get ID, personal, and family. Also, you may have noticed you can change the order of the columns. Before we use select family personal, but you can use select personal family from person, and you get the columns in a different, or even you can repeat columns. Now doesn't make too much sense, but this is also possible to do. So, well, today's lesson will be more interactive. So what I will do is I will type some challenges, challenges or exercises, and you will uh, just let me know when you have done them. So the first one is okay. One second. Oops. Let me this. So first one is using the schema to identify column that contains integers, and the second one is write a query that selects only the name column from the site table. Please let me know in the chat when you are done with these exercises, and we can continue. I see that some people have done already the exercises. What I will do is, well, I will share another link. I will paste the exercises there. Maybe it's easier for you to keep track of the exercises. So, okay, we have done the exercise 1 and 2. Let's do them together. So the exercise 1 says use the schema to identify columns that contain integers. So if we type schema, we have the columns that are integer, for example, are the in table survey taken is an integer, or in Bct the ID is an integer. And yes, I think that's it. The integers that we have in this in the oh, I see that yes, there is a comment that is SQLite supports an autocompletion for the commands with the tab. So well, that's also interesting to know, and is a lot of some tools have this auto completion. I use it quite a lot because it's easier to write commands. So when you don't remember how the spelling of a column is a way also to to avoid errors. So yeah, that's good to know. Uh, okay, so this is for the schema. Not sure. What I didn't mention is the types that we can have. Here in well, you may have noticed that for the SQLite and well, this table we have three types of data of let's say of columns. We have a text, we have integers, and we have floating point numbers that are real. So we have these types of. If you use another database manager like MySQL, PostgreSQL, etc., you will find that there are a lot of more types of columns. But this one, because it's like let's say a smaller version, we have only this, and yes, actually this will be enough for us for for this database. Okay, so now the second exercise is write a query that selects only the the name column from the site table. So well, having the schema here is easier to see the which columns do we have and to type the query. So it's a select. They said that it's only name from site. So here I have the names that is DR1, DR3, and MSK4. Okay, so now let's continue. Uh, what we can do is, okay, we have seen how to select data from the table, but also mm, for example, removing duplicates to see because if mm, I see where the table survey measures are like where I didn't introduce what this database is from. This database are several researchers that are in one part of they said that is in the well, imagine that is in the Antarctic, and what they have some readings. They did some measurements of quant is the type of the kind of a measurement that they did. So, for example, if we want to see what they measure, we can type select quant from survey. What we see the thing here is that we see that mm, there are a lot of repeated values. Well, we can see that there are three different types, but it's difficult to see. Well, because this table is small, but imagine that you have 1,000 columns. Sorry, columns. 1,000 rows. They will be very difficult to know that. So one way to see the distinct types that we have is if we type select this, yeah, I use now tab, distinct quant from survey. If I introduce that, I see that we have three measurements. Is rad, that is for radiation, SOR, that is the salinity, and temp, that is the temperature of yes, the station or where they were. So also you can use this thing for different for different columns. We can have I select taken quant from survey. So you have a taken is the ID of the visit. Each visit they have a number. So for example, for the visit 619, they measure the radiation and the salinity. For the visit 622, same radiation and salinity. But for example, the next visit they measure the three values: radiation, salinity, and temperature. That is the visit 734. Also, before we have for the table select mm, everything from person. We got the ID, the personal, and the family. But imagine that you want to short the data, because if you see the data is not short alphabetically. So what we can do is we can short it using SQL. So the way to do that is if we type select everything from person, oops, person. And now this is a new keyword for SQL is order by. So here you can say order by. For example, we can order by ID. And you see that now the data is displayed ordered by the ID. Also, for example, if you want to show the data sort by the personal name rather than the ID, you can do that. You can do select personal family from person order by personal. And you see that now the data is short by the personal name rather than. Also, you can sort by personal, and let's see if there is a. You can sort by personal and also by family name, because you notice here that you have Frank Pavodi, that is pronounced, and Frank Danforth. So you can sort by personal, family, and you see that now is short first by personal name and then by family name. Also, you can do if you want to short because this is like from A to Z, but you can do the other way around. So you can add desk. So with that, we short the data the other way around. By default, is a short ask in the ascendant way. You don't need to do that to add that keyword, but in case that you want to be explicit, you can do so. You can add this keyword. Uh, what else? Well, also, mm, what I used before, select personal family from person, order by personal family. You can short one field in ascending way and the second one in the descendant way. So you can do something like that. So that are all of these. You can have all of these choices. Okay, now we have let's do two more exercises that are here. Well, actually, I will copy them in the chat. So the number three is write a query that selects a distinct date from the visited table, and the fourth one is write a query that displays the full names of the scientists in the person table, ordered by family name. So yes, same. When you are finished with when you are done with the exercise, please let me know and we can continue with it. Okay, so let's solve them together. Okay, let me check the was write a query that selects a distinct dates from the visited table. Okay, for example, I don't remember the column names of the table, so I can write a schema. And I see the visited have three columns: ID, site, and dated. So they said write a query that selects the distinct dates from the visited table. Okay, so it's select distinct dated from the table that is visited. So okay, here I have all of these dates. You see here a gap. This is because it's a null value. We will talk about that later. So there are like the several visits, but one of them they don't know the date. So because they don't know the date, this is like a null, is a blank. We will talk about that later. And the other exercise is write a query that displays the full names of the scientists in the person table, ordered by family name. So it's select personal. Okay. So it's yeah, personal family from person ordered by family. So yeah, that's the answer, or sort by family name. I got this. Cool. So we have seen how to select data. We can also get the distinct values, also order the data. But what about if I want to filter the data? For example, I want to see the. Okay, let's do first select. Let's show the contents of the table visited. Select everything from visited. Oops. So I see that, okay, you have the visit ID in the first column. The second column is the site that you visit, and also the date of the visit. So, for example, I'm interested only in the visits that took place in DR1. So I can filter the previous query. If I now what I will use is the keyword where. So select everything from visited where site is equal DR1. So if I execute that, you see that we have all the results that we have. The site is only DR1. The others are discard from the query. Also, I can do more. I can do more in where I can put more conditions. Now the condition, the first one is where site is dear one, but also I can filter by the date. For instance, I can say I can say that I want the visits that happen before 1930. So what is the way to do that? Is okay, let's use the same mm, query as we saw before, and we will add uh, a new filter that is the date. So to add this, select everything from visited, where site is dear one, and dated is less than the date that, so the date is 1930 minus 0101. So 1st of January of 1930. So here, now you see that instead of 3 rows, I get two rows. And the date is, okay, the site is DR1 and the date is before 1930. Here in the documentation explains that we have in the for other databases, database managers, we have a special special column type that is date. But for example, here in my in SQLite we don't have that. But what is the way to solve it? We can use we can use a text. We can use the format year, month, day, and we can work. That format will work if we want dates that are less than a certain year or are greater than more recent, etc. Other ways, okay, you can use also a number. Uh, Unix, the way to store dates is using a number that I think is from a certain is the number of seconds since 1st of January of 1970. But well, this is not like a quite readable. So, for example, for this database, a good way is to use this format: year, month, and day. Okay, so we have seen that we can use the keyword and, but also we can use, there is another one that is or. And well, you have seen that now this is like a, let's say, a longer query, and also a way to write a query and make this like a more readable. But okay, because these ones are small, this not, let's say, it's not needed, but in case that you have much longer queries, a way to write them is you use select everything, enter, from, visited, enter, where site is equal dear one, and dated is less than 1030 0101. And now don't forget to type the semicolon and you have the results. So for example, in that way, you can type when you have a query that is bigger, you can use that way. Can use select whatever from the table where, so you can divide the query in that way. Okay, let's see an example that we will select data from survey for two different researchers. So the way to do that, well, for the research lake and row. So the way to do that is we can do select everything from survey where the person is equal lake or person is equal row. Oops, row. So you see that yes, the two persons that appear in the column person are either lake or row. Also, another way to do that, if you don't want to use or, you can use the keyword in. So it's select everything from survey where person in, and now in brackets you type the researches that you want to, the list of. So we will have a lake, comma, and a row. So now if I execute that, I will get the same result as I got before. So this is also another way to type the where condition. Also, you need to be careful when you combine the and or, because sometimes you can get a result that you don't want to. Well, we'll see an example. Imagine that I want to get the results where the measurement was the quantity measure was the salinity, and the person was either a lake or row. So this is possible. You can combine that. The way is select everything from a survey where the measurement, the quantity was so the salinity, and the person is a lake, or the person is a row. Oops. So if I execute that, I will get the results where the measurement was salinity, and only taken by these two people. So I see that the table is, well, if we see the last row, we see that the measurement is the radiation rather than the salinity. So we made a mistake. What was the mistake that we made? That the condition is where the measurement was salinity, and the person was lake, or person was row. So uh, let me uh, the last row didn't meet that, so the person is not a lake and is a salinity, but it meets this part. Person is a row, so that's why it appears here. So the way to do that is you need to use brackets. So if we add if we have this here, so where the measurement is the salinity, and the person is either one or the other, we will fix the data issue. So exactly is the order of the priority in an or that uh, is quite tricky to know if the conditions we will read from left to right, or from right to left, or the priority. So in order to make this more readable and to well, to get the result that we want, in this case we need to use brackets to tell the database manager the priority of and or. Also, imagine that you want to we have seen before that we have a okay in the table visited, select everything from visited. We have three different sites, DR1, DR3, and MSK4. Imagine that I'm interested in the ones that starts with DR. Also, there is a way in MySQL to get that. Is select everything from visited, where site, and now this is a new like, and here I introduce a pattern. The pattern will be DR, and I will use the percentage sign that is like the wildcard that if you remember we use the same for make. So if I execute that, you see that the site is either DR1 or DR3. And also we can well, this in the we can use a combination of uh, di distinct and where. So for example, there is a query in the documentation that said select the distinct person quantity measure from survey where person is either lake or person is row. Oops. So for example, here you see that the person lake, the measurements were measure everything, salinity, radiation, and temperature, and row was only salinity and radiation. The person didn't measure temperature. Also, is important. Well, you may have not. It's important, for example, to reach this query or to get the result that they want, to go step by step. So step by step, for example, to get this query, so you can do is select. Okay, we want a person and a quant from survey. So for example, you can execute that and you get this result. But okay, you don't want you want only this for two researchers. So now this query you can add that filter where person is equal lake or person is equal row. Okay, so now you have these results, but okay, now you see that that works, but you want to get distinct rather than, so now you add distinct. Okay, so this is what I want. So I got it right. So they said that you need to like grow the queries like a step by step. Well, this can be done in, for example, in these small databases, is okay because you have a small amount of rows. But this approach, you should be careful when you have a database that imagine that the table contains 1 million rows. If you type select everything from a survey, uh, will take a lot of time, will print data and data and data, and you may collapse the the terminal. So also, yes, you should be careful with this. But yes, the recommendation is like to grow the query like from a simple one. Start adding filters, start adding maybe distinct, order by. Uh, and in that case, is will be easier. And in case that you find an issue, will be easier for to fix it or to find what it happens. Okay, so now let's do two other exercises that are in the shared pad. Anyway, I will copy them here, but I'm not sure if the format will be mm, doesn't look quite right. But well, if I think is if you go to the if you go to the shared pad, you will find them and maybe they looks better than in the chat. And once that you have the solutions for 5 and 6, please let me know and we can solve them here together. Is that one? Let's copy and paste. Okay, so we have that query, and they said that this y is wrong. So let's see. Okay, let's see the result. So mm, this is related. Okay, yeah, the problem is because they said that there should be between between minus 48 and 48, and there we see that doesn't work quite right because uh, these two conditions are not doesn't meet at the same time because we use or. So the way to fix that is use and. So okay, using and we got what we want. So that we want the sides that are between minus 48 and 48. Um, yeah, sometimes it could happen when you write some conditions that you can use or rather than and, or in this case, yeah, it's quite easy to see, but in other cases, could take more time. Okay, and the other one is normalized salinity readings are supposed to be between 0 and 1. Write a query that selects all records from survey with the salinity values outside this range. Okay, so is select all records. So if okay, let's select everything from the table. These are the table survey where, and here is the key, These are salinity readings. So we need to filter the type is sol salinity, and should be like between 0 and, well, no, they said outside. So it's similar to the query that we have done previously, like we need to use brackets to. Here the reading should be like greater than 1.0, or reading should be like smaller, less than 0.0. So if we execute that, okay, so we got two readings that are not, because are greater than one. In the documentation, they type this comparison. They add brackets that this is more if you want to be like a very sure or very certain that uh, mm, the condition is met, and we want to increase readability, but uh, well, it's recommended, but maybe it's could be sometimes could be quite too much to add a lot of brackets. Because also, for example, here we can also add if we want a bracket, but okay, this is like a, well, we got the same results, but yes, we need to use brackets when they are needed. Okay, so these are these two exercises. Uh, okay, I see that we are. Okay, well, okay, we have 5 minutes. Okay, I think we have time to see that. Uh, well, but what I will, well, we will see this later. What I will do is I will explain because today we will have a longer break. Uh, we will have, well, a longer break. We will have 15 minutes from quarter past 11 to half past 11, and then we will have 15 minutes for a survey that I will appreciate if you do that. That is that survey is a feedback for us to see if the course meets your expectations, or if you are happy with the course, or things that we can improve in the course. Because yes, these courses are offered by the Archer 2 service, and we our goal is offer good quality courses and improve the course in each iteration. See the things that we have done well, and keep doing them in that way. And if we have done something that could be improved, or something that you are not happy with, or you are interested in other context, whatever, we are very happy to listen and, well, read your feedback, and in order to improve courses for the next iteration. So from after the break, we will have another 15 minutes for the survey, and we will come back and quarter to 12. So what we can do is yes, we can have a let's have a break now. What I will do in the chat, I will share the if I find them, I will share the surveys that Okay, so the first one is this. And in case that you have time, if you don't have time now, you can do it after the lesson, that's fine. Is this other one, because this other one is a little bit longer, and you can do it this afternoon, for instance. But okay, also you have 15 minutes to fill both of them. Okay, so let's start the break and see you back at quarter to 12. Hello, welcome back. Let's continue with the lesson. Well, first of all, also before I forget, a reminder that uh, during these 4 days we have seen this material, but you will have time to check the material again and do some practice. There will be in case that you have any questions or you want to mm, yes to practice a little bit more. There will be a follow-up session in the 18th of February at 10 a.m. You will receive an email later with that reminder, with that information. This session is optional and is just in case that you have any questions regarding the material that we have seen during these 4 days. Okay, so let's continue with the lesson. I will share my terminal. One thing that we can do is we can get data uh, from the from a table, and also we can do some calculations with the data. Uh, okay, now let's start. Let's select the reading from survey where the measurement was radiation. So we got these readings, and for example, we noticed that these readings are wrong, and we need to correct them upward by 5%. So what we can do is we can multiply by 1.05 the the column reading, and you get that the column multiplied by 1.05. Also, for example, for the readings that are in temperature, you have the reading in Celsius, but you can have the reading in, for example, you can translate that to Fahrenheit. So what you can do is you can type select taken, and well, let's first have a reading. What I said before, like start growing the query rather than writing everything at once. Go step by step. From survey, oops, where the measurement was the temperature. Okay, so I have that, and what I will do is I will translate that to Fahrenheit. So I will use okay the function round, because the results will be round to two decimal places, and the operation is 5 multiplied by reading minus 32, and then I divide by 9. So if I do that, I get the result in Fahrenheit and down rather than Celsius. Okay, notice that I'm doing the other way around. Is the temperature was in Fahrenheit and I'm translating to Celsius. Sorry about that. So, well, you see that now the column names is well, the first one is taking, and the second one is this operation. But we can change the name of the column if we add select taken and the operation, and we can say as Celsius. So you see now that the column name is Celsius. Also, we can do some we can do other operations with the strings. We can do, for example, if we want to have a column with the name and the surname, just one column. What we can do is we can use select personal two vertical bars that this means concatenate. We will introduce a space, another two vertical bars that because we will concatenate with the family name from person. So I get one column with all of these. And also I can use family as a full name. So I can have a column called full name with that. So as you can see, we can work a lot with the data. And another important thing that is explained here that the example that I will say is not very, let's say, is not very useful, but we will do an exercise that you will see why that that operation, why this operation makes sense. The operation is called union. The thing is, you can have two queries and you can join the results in the same query. So imagine that, okay, and of that, imagine that you have you want to select everything from the table person for one person and from other person. As I said, this example is like not very mm, because you can do it in an easier in other ways, but this is an example to see how it works. So the is select everything from person where ID is equal there you well, okay, we'll see the results of this for example, and we will see the results of row. So we have an entry for William and an entry for Valentina, and I want to have both a query that the results are both of them. So the way to do that is take these two queries and join them with the keyword union. And now I can, well, can copy and paste and type the other query. So I get select everything from person where ID is dire, union, select everything from person where ID is a row. If I execute that, I get a union of both results of different of two queries. Why would I need to know that? To do the following exercise that I will copy in the chat. Well, actually, we have two exercises. So let's do. I will copy them here. Oops. So I give you around, let's say, 5 minutes. Please make these as two exercises, and when you are done, please let me know, and I can continue with the lesson. So yeah, we still need to see more useful stuff regarding SQL. Uh, in a different way, using a percentage rather than. So you needed to fix that measurement only for the entries that Valentina did. So the way is you do a select everything from surveys where the researcher is Valentina. You do the modification and then you do the union with the rest of the research that didn't do Valentina. In that case, you can do a modification of a subset of the. Anyway, we will see the solution now. Okay, let's start the the first. Okay, the first exercise they said that exactly the Valentina introduced the percentage rather than mm, the well the value divided by 100. So we will okay. Let's fix that. Let's is a select well can yes have a taken reading. Well, first we'll see the values from a survey where the person is well, we will use the ID row and quant the measurement is the salinity. So we see here that the readings are 41 and 22. So that's not right. So we take the previous query and we divide by 100. So now the results are okay. But what I need to do if I want to have like the whole table of results? I don't need to divide all the readings by 100, just the readings that are from Valentina. So I take that for the previous query. Well, what I can use now is to make it more clear, I will use enter union, and now I select mm, the opposite in the other query. So the opposite is select taken reading. Here you notice that I don't divide by 100 from survey where person we haven't used this before, but this exclamation sign and equal. So that means that the person is not row. Well, Valentina, this is the ID, and the quantity. I mean the type of measurement is salinity. So if I do that, oh, okay, well, we see that we had an error, and the message said error, no such column, take, because okay, I need to union. I will copy and paste for simplicity. Now is taken, not take. So now you see that you have the results fixed. You have fixed a part of the results and the other are right. Also, what you see here that you have reading /100, but well, you can change that with us. Okay, so let's continue. Uh, Before we talk about the data that is missing, that is when we do a select everything from visited, you see that here there is a gap. There is we don't have any date. We can tell SQLite to show rather than show an empty uh, value that you don't see, you don't understand what it is, or where it's more difficult to see. You can specify dot null value. For example, you can use minus null minus. You can use that, and when you execute again, select everything from visited. You see here now this word rather than an empty space. This is to improve the readability of. Actually, well, haven't covered that, but it's not recommended to use because okay, here you can use that string, or you can use zero, or you can use another thing that means that you don't have a record of that data. But the recommendation is to use null. Null means that you don't have any information about that data that is missing, and it's important to have a for example, we will see later that for some operations, for some SQL operations, null is not considered in the when you find a null is not considered, and is a way to have a for the data that is missing, like not to take it into account this. So what now what is explained is like we can if we want to select this for example this row, one way that we can think about is select everything from visited where dated is equal null. But you see that it doesn't work. Also, it doesn't work if we say that is we want to get the entries that doesn't have any null in the date. The way to do that, the keyboard is is select everything from visited where dated is null, and in that case we got this. If we want to get rid of the dates that are null, is not null, and you get the rest of the. There is a question that says, is the ordering of conditions and after where important? Uh, as long as you use, for example, brackets to, in case that you have some precedences, I will say that are not important. Uh, also another thing we don't know, or what this is like a more specific for each database manager, how the conditions are evaluated. So I think for each, in case that we use MySQL, or if we use SQLite, or it depends of the database manager that we use, uh, we might need to find if the ordering in the where statement is important or not for the efficiency. Now I cannot give you an answer. I would say that okay, it's not important, but maybe it is. It depends on the database manager. So what is important is to use brackets when it's not clear which which conditions should be evaluated first or not, and that's it. Also, for efficiency, was sometimes you can was sometimes I have seen that you can do a first you get a imagine that you want to get the readings of a given number. So you create a table with that readings of imagine that this you get the readings from 1920. And now that you have that table, imagine that the original table is 1 million entries, and this new table have let's say only 100 entries. So from that table you can do further queries, and in that case you gain efficiency because you are doing queries on a table that is much smaller than the original table. So also this is a way to get more efficiency. But yeah, this is now we are playing with smaller samples, but when you have tables that are quite big, yes, you should be careful on how the queries are written, and you need to spend more time having a look at that. Okay, so this is to get the queries that are that are that contains a null, and also well, in the documentation they explain that when you have a when you select, for example, you want to select all values, but well, let's type the query. You want to do this. Select everything from survey, where the quantity measure is uh, salinity, and the person is not lake. This is an using ID. So you see that, for example, that is a well, we have also a person ID that is null, but here is a filter because mm, mm, because the null means that we don't know the data is missing, so they don't know if the was taken by lake or not. So when you do the query, this also filters the null in person. If we are interested in include that, I need to rewrite the query using now brackets and say or person is null. So you see that now in person we include this null entry. So you need to be careful with that. We have some exercises, but what we can do is we can solve these exercises together, and we can see like because I would like to complete the lesson and don't leave things that we haven't seen. The two exercises that are in the pad and are is the write a query that sorts the records in visited by date, omitting entries for which the date is not known, so it's null. So let's see how let's write this step by step. So it's a query that okay, the table is visited and we want everything, so it's select everything from visited. And we want to order this by date. So it's order by date. Okay, if I do that, we get this table. But what the exercise says is that we don't want these dates that are null. So how we can remove that? Using where. Is in that case is select everything from visited where dated is not null. So in that case, I filter first. I do this filtering where dated is not null, and once that we have the table, I order the results by date. Also, what we have learned before, you can use from you can use descendant and you can get the other way around. You can get first the most recent dates. And also this is well a question that is they ask you what will be the output of here. They ask you if you will if null will be considered. So the answer is I would think that yes, null is considered, so they will show you this date, but actually this is not considered here because is what I mentioned before. Null is a value that we don't know, so a lot of times, well, a lot of times, the SQL manager avoids considering null. So the query is the same as we have written this. I mean, if the way to fix that is to use dated equal that or dated is null. So if you want to show null results when you do a filtering with where, you need to use is null. Otherwise, they will not be considered in the filtering when you use where. Okay, what else? Next thing is aggregation. With aggregation, we can do some operations on the data of the data that we have in the table. We can get how many entries we have on the table. We can do some get the maximum, the minimum, average, etc. So we will see an example now. Imagine that okay, let's work with the dates. So let's use a selected dated from visited. So you get this, and now you want to know how many dates do you have. Well, this is now what I will explain is because I think we will have a different. Here we have 1, 2, 3, 4, 5, 6, 7, 8. I have a 8, but if I do so, if I do select, I can do select count dated from visited. So if I do that, uh, also this is important. Here I have, you see that I have 8, but one of them is null. When you do the count, omit when it's a null. So they show you 7. So for example, this is important to bear in mind because, for example, if you do the average using well, there is a function that you can do the average. That is, let's see, that is a select average of the reading from survey. Well, okay, where the the, the measured quantity is the salinity. So you get this. But the problem is if you use instead of a user average, if you use the sum and then count divided by count, you will not get the right average. So okay, the functions that we have, the aggregation functions that we have count, that is the number of elements, average, and also we can have we can use, instead of the average, we can use the summatory of all the values. That is this one. Also we can use, we can do the maximum, we can do the minimum. Oops, there's an error, no such a function because it's a n. So we have all of these. Also, normally you also use when you want to know the number of columns, sorry, columns, the number of entries in a table. Normally you use select, count, and you use a star. And that means you get, okay, from survey, you get the number of entries, that in our case is 21. But yeah, you see, you need to bear in mind the previous example that if there is a null, it's not considered in the when you do the aggregation. Also, this is to get the you get like a single value, but you can also get, for example, the okay, what is it? I mean, you can use normally aggregations. Another thing that I didn't is the group. You can use the group by for aggregations, and you can have like imagine that you want to okay, and all of that. You want to get the how many readings did each researcher, and also get the average of these readings. So what you can do is the query will be select person. I want the count, how many readings, and also what I want is the average. So I will do average of the reading. I want that by per person. From survey where, okay, I will select the radiation measurements. And here is the key, is group by person. So if I execute that, I get a person, for example, the first one did two count and the average was 8.81. The second one did 2, the third one did 3, and the last one did 1. And you get also the average. So it's quite useful when you want to get like imagine in that case statistics per person. Also you can get statistics per measurement, type of measurement or whatever. You can it's quite useful to use the aggregation functions and also do a group by. So you can get for each, in that case, for each person, the count and the average. Also, you can do, you can get, you can group by several columns rather than just one. You can include select person and the measure that was the type of a measurement count from survey uh, group by person and the type. So if you get that, you get that this person did for radiation 2 readings, and this is the average. The same person did for salinity 2 readings, and you get here the average. You have you can have like further statistics. So you can have the measurements grouped by person and also grouped by quantity. Also, if you don't want to, you can get rid of these null readings if you include here where person is not null. Also, you can do order by. You can have a complete list of. Can do is I can copy and paste this. So, for example, you can do this. Select person, quantity, count, and well, the average is around with the 2 decimal places. From survey where the person is not null, group by person quantity, and order by person quantity. So you see that now, for example, this query is much more complex, but okay, you want the data in a nice way, sorted by person, by the type of measurement, reading, count, etc. So okay, if there are no mm, questions, I will. If you have any questions, please feel free to ask. If not, I will continue with the lesson. That now what we will do is we will combine tables. Mm, if I do okay, let's do this example. I have let's do select everything from surveys. Okay, doesn't exist the table. This is the table. So here I have the list of, okay, taken person, quantity, and reading. And for the person, I have the ID, but what is the name? What is the surname? I don't have that information. How can I get this information in the same, let's say, in the same view? So I can have, I can join these 2 tables. Actually, it's good to have this information separated from here, because imagine that for the person, for the name, we have a typo, and we need to update the name of the person. Imagine that the person for, don't know, they change the name, or uh, you can you can go to the table that is a person. Let me see, from a person. You can go there and update one. For example, you can update that name. And in that case, you don't need to update this entry, this entry, this entry, this entry. The update will be much easier. Okay, so let's go back to the table survey. So what I want to have is the name and the surname in that table as well. So, well, in that table, in the view that I will have of the table. So what I can do is select, oops, select everything from surveys, survey, and now is join person. Okay, if I do that, what they will do is mm, okay, it's a little bit of a mess because takes this is like a, well, multiplication. Add, for example, for this entry here, add this this part of the person table, add this, add this, add this. So you see that doesn't correspond this with this. For example, this is okay because this ID and this ID, well, the person ID and the ID are the same, are this and this. But for example, this doesn't work because the person ID that is in the service table is not the same that the ID that they have in the, sorry, in the survey table is not the same that the one that they have in the person table. So what we got is, well, this is called a cross product of two tables. So for each record joins the whole table, but we don't want that. We want to match by the person ID. So the way to do that is let's use the same query, select everything from survey, join person on, and here I specify the condition that and also for the join I need to specify the name of the table that will be survey dot person equal person, that is the name of the table, dot, and the name of the column, that is ID. So if I get that, you see that now I get the table, and now I get the name and the surname. And you see that this that is the same. So now the join was correct. If I want to clean a little bit because for example, I don't want to see the ID. I don't care anymore. So I can do select taken, quant, reading, personal, family. Yes. From server, and now I have a view that is much better. So now I can see instead of see the ID, I see the name and the surname with this join. Also, I wanted here we are lucky that the columns doesn't have the columns don't have the same name. In case that the columns have of both of the both tables have the same name, what we need to do is we need to specify the name of the table. So we can do survey.taken, survey.quant, survey.reading, I mean, to specify the name of the table. But because the column names are not repeated, we don't need to do that. But well, we'll do that, and well, you see that the results is the same. So this is the way to join when we have two tables to join them. Also, we can do a join with the table server. We can join with the Bct or with the site. So we can have like a whole table with a summarized view of or with a joint view of everything. What else I wanted to explain? Okay. The thing that I forgot to explain is the concept of, but in that case I need to show you the everything. Okay, select everything from the survey, join person. So, well, you see that the first four columns belongs to the survey table, and the last three columns belongs to the person table. So here the ID in the person table is is called a primary key. Primary key means that the ID will never repeat in the table. If I do select everything from a person, we see that the ID is never repeated. So it should be unique. So this is the primary key. And when you have like a relation with other table, that's why this is called I didn't mention before, but this is called a relational database because the tables can be related. If we do the same, select everything from surveys, we see that here in this column, the ID, the primary key of other table is used. We call it a foreign key, this one. So this is two concepts that, well, is useful that you know because in other database managers, they will be important. And normally when you do the joins, you use the primary key and the foreign key. Also, you can do joins using like three tables. I will copy and paste this example. So for example, here we select latitude, longitude, the date of the visit, survey the type of reading and the reading itself from a site, visited, and survey. So here we have three tables. And the conditions are, okay, the first one is a site name, should be the same as visited the site, and then visited ID should be the same as a survey taken. If I execute that, I have this table. So this is an example just to show you that you can do a join. You can join three tables at the same time. Okay, what we need to, well, we will do is we will because what we have done so far is to do queries with the data. I mean, get the data, modify the view of the data, but we didn't create or we didn't yes, create of a data table or these operations are possible. Also, is very important because, well, also recently appears in the news that if you type in this case, for example, if you type drop a table survey, the table is you can delete the table and the table is gone forever. You will not it will not you will not be able to recover that table unless you have a copy of the database. You have a backup. So this is very important to have a backup of the of the table. I mean of the database. The backup could be if we go to the okay, let's exit with the dot exit, and now we are here. So if I do a copy, we are using survey. We need to use a survey. Let's use a backup. Okay, so now I have a backup. And normally also well, this is not covered, but also the backup should be in another, because if you have a backup in your laptop, it's fine. It's better than nothing. But imagine that your hard drive gets broken or is a so the backup should be in another place. In case that, for example, there is a problem with your laptop, you can get access to that database in another. For example, in this case, if the database is public, you can have it in GitHub, for example. You can uh, do a copy of the database. So, okay, let's use SQLite 3 survey.db. And imagine that, for example, now what I explain is I do a drop table survey. You see, easy. Just write something, press enter, and now when you type a schema to see what you have you have three tables, and by mistake you drop a table. And if now you type tables, okay, the table is missing and it's gone. There is no way to recover that. So that's why I insist this is very important to have a backup of this. I see that, yes, it's a good good joke. This the link that is in the chat. So okay, because now, for example, this database is not good any longer. Let's well, actually, I will use this same to explain how you can create and update, delete rows from a table. You can do is well, because I dropped the table surveys. I will I can create the uh, okay. Say I can copy a user SQLite, not the git bus, where that line should be typed. Which like I mean, you mean to do the copy? Um, what I explain is that you should have a copy of the. What I did is I did a copy just now, but mm, for example, when from your Windows you can do the copy. This is like a recommendation that you should have. You should have like a. Yeah. Okay. Okay. Yeah. The copy. Yeah. It's a manual copy. It's not. You can use either the terminal or you can use the window interface. Yes, this is like outside the SQL. It's like the recommendation is to have a copy. And for example, Git is a good way to have that, where you can have a copy. Okay, what I will explain is how to well, we have this database that I can do. I will do insert, update, delete. Um, okay. First, how to create a table. So the way to create a table is create table, and now the name of the table. For example, this one, just lat long. And here you need to specify the column name. For example, lat, that the type will be real, and long, the longitude, that also will be real as well. So you have that table, and now if you type tables, you will see that you have 4 tables. Just lat long, person, site, and Bct. Also, you can insert values uh, by hand. That, for example, you can do insert into the table, for example, just lat long. Here you can specify the order of okay, the order of the table is a lat long, but imagine that you want to insert them the other way around, so you can change the order. But well, just to leave a lat long. And now I introduce the values. Values could be no 50, 50, let's say. And now if I do select everything from just lat long, I get this value that is 50, 50. Because I didn't, I now it's not saved. I think it's, if I remember right, it's a header on and the mode column. Not sure if that's the right. Okay, that's it. So now I can see in a better way latitude and longitude. Also, I can insert from other table. What I can do is I can do this if that works. No, doesn't work. Insert into just lat long, and what I can do is I can do a select from the other table. Select lat long, leave a space for more readability, from site. My recommendation is first do this, and if you are happy with that, with what you see, now you can do insert into just lat long, and then the output will be inserted into that. So we'll see now if that works. And yes, we have the value that we insert, and also we have the 3 values that we got from the select. Okay, so we have seen how to create a table, how to insert data. And also imagine that, okay, let's select everything from site. Imagine that you want to update the coordinates of this base, this site. So what I can do is to update a value is update site set, and is the latitude will be minus 47. Well, I will just update the latitude. That is, I notice that is minus 47. Where, this is important, where name is equal MSK4. Otherwise, if you don't introduce a where, this minus 47 will be updated in all the rows of the table. So if you do that, you can see that this value was updated. And also, just to follow the sample, let's delete, imagine that this base is not there. You don't need that base any longer. So to delete is a delete from site where ID no, the name is equal msk4. If you do that, and now you select, you see that we have only these two bases. Also, be careful when you delete something, because if this name is used in other tables as a foreign key, you may have some, well, you should consider that. So, okay, we have seen now in this last part to create a table, insert values, update values, delete values, and also you can drop the table. So, and just to finish and go for lunch, this is possible. You can manage a database using Python. We will see this sample. If I exit from this database, I will create a Python document. So I will use, well, let's use nano survey.py. What I will do is I will copy from the documentation. I will copy this code. Well, actually here I will use the backup that I have created, survey backup. So this code, you see that you get the connection to the database, and then you execute a query, select latitude, longitude from a site, and then you get the results and you iterate in that results. What we will do, we will print the results, but you can do whatever you want. You can modify them, plot something, etc. And then you close the cursor and the connection. Okay, we'll save this code. And now if I type Python survey, you see that that works, that connects to the database and prints the latitude and longitude of a survey. So this is the end of. Also, you can do the same with if in case that you use R, you can also connect R to the database. Okay, there is a question to use SQLite in case that doesn't work in your Git terminal. Uh, uh, it depends of the operating system that you use. You can use let's say the normal terminal, or also there is another way that is called DV for is in the setup is here. I will paste there is explain the different ways that you can. Well, sorry, no, it's not. Oh, well, see, yes, it's for Windows, Linux, and MacOS. Maybe you need to update the path if you are using Windows. Okay, so this is what I wanted to explain about SQL. Well, this is introductory. If you work with more in the future with more databases, you can see that there are a lot of more things that you can do, and also depending on the database manager, you will have more or less options. So yeah, thank you for joining me until the last day of the course. And well, please, if we have 5 minutes for questions. If not, yes, have a nice afternoon, and please check the material. If you have any questions and you want to get an answer, you can join the follow-up session. That will be the 18th of February at 10 a.m. Anyway, we will send an email with a reminder. So, okay, that's me. Thank you so much. And yes, have a nice afternoon. Maybe see you in future courses. Take care.